Good evening. Or wherever you are. Did a bunch of grocery shopping and stuff, and there's still some time left in the day. So I want to see if we can get some more stuff done. We have several DXF. Well, we've got some lines parsed. And we have this sort of like code value association. I assume we're going to have to build some further structure on top of that. Let's see, I think. Was it 70? Yeah, we've done 70. Ten, 20. $49, $970. Wait. No, 71. Yeah, 9 at 71. 9 text size 42. 949. It's 7? No, we haven't done 7. Text style name. Here's just string. Now, this might be enumerable. Maybe this fixed means that it's a finite list of things. Okay, that's like relatively huh. Okay, so these are more examples of particular features. Interesting. Oh, these are vport. So what's text style? Oh, so these have particular group codes. Oh, maybe particular values in some cases. I don't know if I want to get into the weeds on all of this, the details of these. If I was trying to make a general library, then yes. Yeah, there's no indication of legal values. So I guess it's just a string. Okay, now, oh, hey, look, there's an 8. Okay, value types. Yeah, layer name. Ah, yeah, layer 0. Okay. I remember seeing a layer 0. Okay, so 9, 6. You can all these small numbers. Line type name, which is cell type variable. I don't know what fixed means. In the table, fixed indicates that the group code always has the same purpose. Its purpose depends on the context. Wish I knew what that meant. Oop. I've been watching for rain. I got some windows to close. Oh, yeah, I gotta close the windows. This might be a thing that could be enumerable, but I don't know if they have a... Oh, I could search. Yeah, it's not documented here if it is. There's room for a 5, though. All right. 9, 62. Color number fixed. Science! I'm wondering if a helper function would be useful here. Oh, science and technology? Okay. Yeah, it's kind of... It's one of the, like, junk drawers of Twitch. If you actually go to the science and technology category, you'll get, you know, chicken cams and watch pot grow, watch AIs learn. Yeah. There's a couple of tags for there's a programming tag, there's a software development, which I guess I think of as doing more like software you're gonna run on your local computer. There's web development, but this is only web on the sense that Elm is mostly a web language, and it's ultimately going to be in a web thing. But it's still under programming, so eh. All right, I was wondering, like at least for these, if a helper function would be nice. I mean, I guess we're just copy pasting things. Like I would only be able to make it more compact. Oh, actually, this is technically a parameter too. We just happen to be doing all the value stuff right here. Which this could almost be a group. Really. So this is lines. And then all of these types, which... Well, yeah, because we're actually using the number to determine how to parse the rest of it. So it's not like we can just run on the rest. Ooh. Okay, so that's all the value parsers. So this is a lot of run, decoder, on input, expect, okay, blah. What would we call this? Expect parses? Or just even parses? Probably am exposing this right now. That is a DXF parser, which I don't know if I've exposed, all of that. We have an input and a... This might still have to be... Well, your result. Yeah, okay, yeah, I'm rolling a handle the okay case. If not, it failed. Yep. Apparently animals are popular. Well, yeah, there are definitely times where you just kind of want to sit back and think quietly, and that's not a great thing to be streaming. Oh, and you give... Oh, what does the test package return? It's just not Elm test. Okay, it's just test. Expect. So I think it's an expectation, I guess. I don't know if we've imported expectation. Oh, it doesn't give me a label. I almost want to say, this doesn't tell me it's a line type. Okay, we left a comma lying around. The body is a test. Oh, that's the expectation part, which we could leave the test there to have the comment. That would just compactify this part by a very tiny amount. Okay. And if I were to make a specialized version of that, it would just end up being something like parses value, which wouldn't really change things all that much. Yeah, I never have gotten into that stuff. Maybe I should have gotten a small amount back when I first heard about it, and it could have turned into something, but I'm always thinking, it could crash tomorrow, and it'll be worth nothing. Converting these is kind of annoying, though. All right, done with that. Too much. So I kind of wonder if maybe the like parses as would be a better. Oop. In the whole test. Maybe that'd be worth still having in case anyone wants to do something with a more explicit name on it. Okay, too much. Do that. That's one word. Do that. I guess I could have actually macroed this probably. I think even these will fall under that. Although this is the case where the labels are a little bit more instructive. So that does have a nice syntax of we parse this value and then we expect it to equal that. If we're saying parse as, like we're going to say like what it parses with. Another way to put this would be input on parser, or maybe you could put something, a sort of wrapper around that, and then expect equal. It's kind of transformation pipeline style. Yeah, where do you put the parser itself if you do parses as blah? Is that another coin or just another fad? Okay. Is there anything notable about it, or is it just another coin? Yeah, I'm not sure what that would look like. The only thing we can really get rid of is the OK, I guess. All right, so what do we run into? We're going to do a 62. Color number, CE color, okay. That's 16-bit integer values. I don't think we're going to be parsing that any differently for our purposes. It's just going to be an integer. Disk space for sort of high-end custom. Huh. Okay, yeah, I've heard of the memory hard problem, so you just put it up a few orders of magnitude and disk space becomes a factor. And maybe it'll drive down storage prices, right? Oh, actually they did. These got indented. So this... Oh, so actually these were technically indented too, I bet. Yeah, so this is actually allowance for a 3-digit number. Oh, yeah, I didn't think about that. I already passed up replacing the graphics card on my last run, at least for the time being. Figured maybe do a ping pong upgrade, and then it's like a. I think even my old current card would have cost more than I originally paid for it. Okay, so all that says is 16-bit integer. We have to go here to see that it's a color number. Now, for documentation purposes, there was technically another type that was, let's see, 16-bit. Okay. These were double precision floating, which maybe I hadn't actually hit those yet. We did have one float value, which I know I punted on. Double precision 3D point value. I guess that still means it's float. I don't know if there are any other precisions of float. Now, I guess my type for this was also int. But if I had anything for it, it would just be an alias, so. All right, so 940. Double precision 3D point value, double precision floating value. Text height, scale factors, and so on. Oh, so these are for when things can repeat. Or the nines of groups. Huh. We'd already do some kind of float value. Those appeared in XYZ. This is just some other number. So 48 appears twice in this, actually. line type scalar. Huh. I guess that this is that, you know, this type still applies to it. We don't actually have to worry about a 48 at the moment. Oh, I just called this integer. But I can't call this float, I don't think. Right, because it's int. I did integer. Oop. We're not going to actually need that, so I won't test it very much. All right, so I think we did 70. There's 40 again. There's 40 again. There's 40 again. '40's popular. 40 and 70. And 70 was integer values. Okay, so it's int float, int float, int float. We've seen one before, I think. Primary text value for an integer, and it was just blank. Oh, names for dimensions? Dim block. Dim block. I'm pretty sure we've had name. Yeah. Seven was like line type or text style. I know we just did 6. Oh, there's a 50. Must be an angle of some sort? Angles. Output in degrees. To DXF files. Double precision floating point. Should this specify the unit? Yeah, I guess angle is more essential. If I want to get fancy, I could specify it as a type. All right, so we have an example of a 50. Some of these things have other interpretations beyond just their data type. Oh, this one actually is just 50 to 58 angles. Didn't like getting changed during the run there. Five? No, we haven't hit 5 yet. Oop. Like all those are strings. Entity handle. Oh. Text string of up to 16 hexadecimal digits. So we'd actually want to parse this as the hexadecimal digits to do it proper. "16 hexadecimal digits" is probably, I forget what bit length that represents. I guess we can just call it an entity handle for now. And hey, what do you know? We're already doing a type chomp here. Now, if the standard parser does a hexadecimal, it's going to be looking at a hex number. We don't really want it as a number. Now, does our char package have is hex digit already? Is hex digit. Should I just return you as a string? It would only be an alias. Okay, 970. 2 is a name. 10, 20, 30. Wait, okay, so those are some new ones. Cell weight, 370. More 16-bit integer values. Okay. Must have some meaning. Line weight enum values, ACDB line weight, stored and moved around as a 16-bit integer. Custom non-entity objects may use the full range, but entity classes only... Oh, this is a range. Use 371 to 379. Otherwise, assume a 370 is the entity's line weight. May use the... Oh, stored and moved around 60. Custom non-entity objects may use the full range. Entity classes... Common entity fields. Well, hacks upon hacks, okay. Oh, entity handle means we may have been like defining some default object? Or did I actually overlook like a section transition? And it's -1. But I don't know what an LCDB line weight is. That actually means unset, I guess. And that's weight. Okay, 1 of 4, that's better. No, this is somehow marked to be not searched? It's right there! I'm literally looking at it. I guess it's marked as unsearchable somehow. Okay, it's highlighted when it's on. Yes, I have no idea how to interpret that right now. Well, there were some other... I searched around and there were some other online versions of it. Oh, this isn't what I hit before. Oh, yep, same thing. I hit some online versions in... They're also in AutoCAD, but they're like importing and exporting. This is probably more app level. What did I search for before? Not 2012, PDF. Release 12 contains information. Many books have been published. Huh. I did find some online versions of this. Maybe it was these? Well, that's 1995. Release 12. Okay, release 10. This is similar. And this just redirected to their top level page. Yeah, this is not what I found before. Yeah, this is not... Wow, this is shallow. Okay. I think I continued some previous search or something. But yeah, I did find some other references that might have been newer stuff. Wonder what I was searching for before. Yeah, everyone goes off this 2012 PDF. File formats FAQ. Different versions. From release 14, 1998. Okay, gone. Internet File Archives. It's FTP. This is R13, which I think the things we're really looking at are beyond that really. Oh. Well, this is the Wayback Machine, which actually has the pointers to those things. Now, whether these files are in the Wayback Machine... This gets us up to 2014. So there was already one code that I guess I didn't... Yeah, there was one code that we were missing, and I just kind of skipped over it. But I guess that PDF kind of goes back to this stuff. Which they no longer index. Now... Do these have the same file format? ADSK files. AutoCAD 2014. Now, they may have stopped doing this. Now, I don't know what the... So is this one still there? Okay. Nope, this one is not still there. Everyone's pointing to the one that is still there. But this might be... Oh, this is a pop-up, so I can't really... Well, I downloaded this. Wait, did you? Yeah, you did. So in theory, that supersedes this. (16-bit integer value). Oh, we were looking for line weight. Well, there's more of them now. Standard bilayer. Oh. 70. Interesting. So that might document what the possibilities of that are. But maybe one of the possible values is a number. Enum value doesn't specify what the ACDB line weight thing is, though. K line weight by block. Oh, maybe that's the internal name for that enum. Yeah. Whatever this is not defined. So we did find this, but it suggests that, well, this is a numerical encoding. So that, well, this is actually 70. 70 is, no, 70 was something else, wasn't it? Integer. Yeah, 70 is an integer. That was a text. So that might mean... Were we in fact looking at... No, this is a -1. Which implies, as we find here... Well, not 70. Line type is bilayer, standard, and by block, maybe. Of course, does that mean that this text style is in that format as well? We don't know. But if that's a line weight and dimension line weight can be -3, -2, -1, or an integer, That might be the appropriate interpretation for that. Of course, then we've got this thing as the line weight value, and that would be like a line weight type. Or we always do like line... hundredth of a millimeter. Line 100 millimeter? Wouldn't read quite right. The other problem with that is that we do have standard and bilayer being used elsewhere, so if those were the names of things in this line weight enum, then... So I might have to punt on that one for the time being. I think when we were looking at these... Well, right, it said it was a 16-bit integer, but it was part of an enum, which we just didn't have any definition for the enum. So that type is there. This said... may use the full range. So it is kind of defined as a 370. In their representation, because AutoCAD and Autolist both always assume a 370 group because the entity's line weight. Line weight enum value. So it's the entity's line weight versus the line weight of something else, I guess? I guess? And if it ever matters, it's that. All right, I'm gonna take a short break. I'll be back in a bit. So it's getting closer. I guess I could do a double on that one. That would change that. But then I can't do anything with this one. Because anything I do there will double up that. Does that even work? Well, it doesn't blow up. There. All right, metals, not a big deal. Well, I was trying to replace my compound. Use titanium for oxygen tanks. Yeah, I feel like we're just kind of going around in circles now. Well, it might be comforting to actually go around in a circle. Or we could crash. Yeah, is this a ceremonial murder shirt? Welcome back. Alright, we had a 280. Which is just, well, it's a several space. Oh, that was technically a several spaces. So there's 1, 2, 3 spaced there. So you're probably the same. Yeah, those line up. So probably another 16-bit number of some sort. Okay, by type, 16-bit integer. Oh, wait, this is the type reference. So that is just a 16-bit integer value. Now, when I just did integer before, what did they say that was? What am I using that for? I'm using that for 70. See 79, 16-bit integer. Okay, so actually, this is that. Oh, but these are used not necessarily in bit width, I guess, but that does specify a 16-bit integer. And I guess 280 is more just 16-bit values. I don't know. I have no evidence yet that the use of these is any different. It's like they're encoded as different things, but they're just 16-bit integers. So I don't know why that would be different. So either we don't handle negatives, which I'm vaguely having some reminiscence of that issue with the default parser integer, or it doesn't like the spaces. I guess when I set these up, I just was taking examples, and I never said, oh yeah, it's a integer. Of course, I guess without an example, negatives can appear there. We don't actually know if negatives can appear there. Do we have that issue with floats as well? Yes, we do. Just silently ignore giving an example showing us that it doesn't handle negatives. Weird trailing characters. But it can get confused by them. Okay. For int, if you want to handle, you do it with a custom parser. Well, fortunately, we've kind of got a custom parser here. Yeah, no, actually, we've got places for them. Now. Oh, you have to do it. So that's a one of. Okay. Could we do something like that? Because it looks like it would fit in there. Okay, this is a little short right now. DXF parser of... We're going to call negate, which probably works on number. That'll probably constrain our type a bit. Negate a bull, eh? Oh, we went into basic parser. Which this doesn't even touch on that. But we now have to do this fancy pantsable. Or maybe it's just, it takes a token? Token with an error. Okay, so that fixes that. Huh. Maybe did this pass before because there wasn't space here? I guess at a certain point in development, they started adding new attributes with slightly different data types. 290. Boolean flags. Which are apparently 1-0. It's probably be bool value because bool. Actually, there probably not gonna be a generic parser for this. Because like, how do you? Is it true? Is it false? Is it 1? Is it 0? Is it T? Is it F? Most of these don't require. His entity handle is a custom type. This is gonna really just be a one of. We have to figure out how to write that. As it could be an integer that we check for a value. And you take a function, don't you? In the standard version. Actually, that doesn't matter, so I don't need to pass anything to it. I'm going to treat this as a token. Oh, and actually, since this is a value, we need this on the whole thing. Oh, you can have leading spaces. So actually, some of this other stuff, we did like, I just found float value. Yeah. Spaces new line. So we've got the raw boolean, and then we've got, how do we throw that in? All right, 79, 1919, 290, 380, 290. 2, we found these when we were looking at 2 earlier. So it was, okay, just some string. 40, 290, 280. Don't know when I started using these. That is a 347. String representing hex object ID. So it's an entity ID versus an object ID. .340 is a hard pointer handle within same DXF file or drawing, translating during insert and XREF operations. So I guess all we can say about that is hard handle, hard pointer. And it was an object ID? Object ID. All right, so this is not necessarily an entity handle. This is, now you see, that's an object ID. This is a handle. I mean, probably those are kind of mean the same thing. Now 347, 266. There's not actually any particularly interesting hex characters in here. Since these are IDs, I guess they could be numbers, but it's stored as a string, they say. Oh no, and then this said it was an object. Other objects, whatever that means. Okay, now what? Oh, right. Where'd I put int? Right, because I was next to this. Two 280, 290, 62. Okay, so nsect and section are going to have meaning at the next layer. One and 3. 3, 4 text string. We haven't done 90. 9091, 280, 281. Interesting. Why did I put both of those in there? "32-bit integer values," which I guess this is all that says. We don't really have a way to represent that right now. So we're going to lose a little bit of precision there, or exactness about what type it's using. So technically, these are 16, and these are 32, so that's a little... Don't know if I like that much. Oh, you're good at 99. And then 280 and 281, we just did the range. So that should be fine. 1, 2, 3, 991. Why do these always appear in pairs? Is this like... Well, no, because that's 2. 16-bit values are 32. And then we have 2 32. So it's not like it's like extended bits. Okay, so this looks like stuff is starting to happen more at the key value level than at the group code level. And that's a 5. I think we've got a 5. Hex ID. 22B, okay. 330. Is that a 100? 522B, 330. $330, that is a soft pointer to 0. Representing text object ID. Oh, I left use a... Because it's 0. It might be appropriate to turn those into integers. I don't know. String. So in theory, these have a maximum size. Subclass data marker. Segregates data defined by different classes in the inheritance chain for the same object. This is technically a data marker. Right now, this is a single. $70.05, 330, 100, 100, 70 coordinate. Oh, well, there's some 11, 21, 22. We do just kind of treat those uniformly right now, which I don't know what this means. Viewport table record. Maybe it's a matrix? Oh, wait. That's getting into some 50, a 62, 70. Do we do... No, we kind of skipped over the 60s. There's a 281, 110, 120. Appears only if code... Oh, so code 72 is a special thing? Repeat counts, bit flags, or modes. UCS origin. Double precision floating point value. Okay. 0. Okay. Wait, I think it's the only floats I've seen so far. Zero point zero. CS origin, you are a float value. Oop. Okay, we've got we got a whole bunch of stuff here. Y value of UCS DXF. So this is like some weird multi-format thing. I think this is DXF. So this is actually X value. Oh, app 3D point. Now this is some kind of X. Right, this is UCS origin. Wait, wait. DXF X value. DXX X, that's 110. UCS XY XX. Oh, origin XY. DXF XYZ. UCS X axis, UCS Y axis. Oh, and here's the 111 one. Okay. Oh, the 110s have different interpretations in UCS. And are all DXFX. So not specifying how these are different in terms of a 110 versus a 10. So this is just looking like an X so far. And for our purposes, this is actually a range. Zero, zero, zero. Because I have no words to describe how they would be different and how we return them. Oop. $130. Oh, because we did U with the wrong digit. Is 79 something special? We know it's 32-bit integer? No, that's... no. So we know it's a 16-bit integer, but it is actually undocumented here. $146. Points, elevation, dim style settings. But that can mean so many things. It's going to be context dependent anyway. That is yet 249. $348 we should have. 60, we've seen a 62, not a 60 and 61. Entity visibility. And that looks, well, looks 01. But technically it's a 16-bit integer. Oh. And it's a 3. Which is not a 0 or a 1. And 61 is undocumented. Is this to call these integers? We've got 60 and we've got 61. Which is, well, we still know it's visibility. Well, it's documented here as visibility. I don't know if it's still visibility. I'm kind of getting ahead of myself here. And I guess we're going to call you an integer. Because you're undocumented. But it's also clearly there. Do we have 290? Yes, now that's a Boolean. We had the 280 range. We had 140 range. 60, no, we had 62, not 63. Also undocumented. $361. Hard owner handle. Went way too far for that. And I feel like they are mixing up pointer and handle a little bit. Okay. Oh, because we have to define you. Okay, and a table. 2, 5. 2, 2, 8? Arbitrary object handles. They're not translated during. Huh. So this is just an object handle. This is a 2. Oh, no, that's a 320. We need a 220. That's a 220, not a 228. Or who's an undefined? Do we have a data type for it? Double precision floating point value. Wait. It's not normally how those are written. Of course, this comes back to this being an older reference. Wait, did I get my out of sync? 2 L type. Oh, this is a 5. Soft pointer 0. $7048.05. No, 0. L type 5. 236. 330. 228 again. 100. 100. 73. We need all of 70. It's just integer. Five, 330, 100, 273, 72, 40. Continuous is a value for 2. Three solid line. Phantom X2. Phantom 2 times, is that like a line pattern? Oh, line type table record. So there's like the on and off periods. Oh, there's a 49. Double precision. Repeated double precision floating point values. So at this level, I'm not dealing with that. A 7x group always appears before the first 49 group to specify the table length. In this case, it looks like it would be 1. It's not immediately before either. 6? But why 49? Oh, no, actually... Is that a 0? No. Six seems reasonable, actually. Huh. Repeated double precision. So do we need to say like repeated float? Since higher level stuff might care about that. Oop, 40. Case match, please. Okay, we messed up our table because that, indeed, came through as unknown code. Wow, this is like having all the line types are defined even though they're not used. That must be 2 entries. You've got a couple of extra numbers with you. We got 340, right? Yeah. Right, 340 is a code. The 46 was in the range. That was not 49. We have 50. Float value. Oh, specifically angles. Zigzag. Hidden 2x. Hot water supply. Oh, I guess if you were doing water stuff. That in code. Well, there was an HW in there. We have 9. String value. Phantom. fence line. I mean, maybe you could go into your file and like delete all these styles, but I guess there was an option to take a sparse file. I guess this stuff makes sense if you customize it, but having the defaults in there seems kind of silly. Then I get only if they're unused. If they are used, it would depend on the program you opened it in. I think we're going to be looking at higher level structures, but lines, 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 lines. Oh, that might be something else. Maybe we're into shapes now. End tab, table, layer. Is 226 a code? Oh, that's one of those undefined ones. No, that's a 5. And 330 is it. Uh, 370. 390. 347. Why 47? I don't know. String representing handle of the plot style name object. It's a different range to make backwards compatibility easier to deal with. Store to move it around as an object ID. A special type in auto list. Custom non-entity objects may use the full range, but entity classes only use 391, 399. That's not 39D. That's the line rate range. Okay, here like common entity fields. They don't specify that. I guess that they expect 390 to be a common entity field. Plot style name. You are an object pointer, though. Well, I copied it in. All right, 347, 348, we technically got, but it doesn't make sense. Wait, 5, 304, 330, 100, we got that. That was the, okay, that's a layer. We're actually going to need that to pull out our objects. 420, 24-bit color. Zero zero RR GGBB. $32-bit integer value. Yeah, this is a little bit confusing because they're saying here's the 32-bit value, but in decimal, so I'm not sure. Well, I guess 32-bit integer would imply the decimal equivalent. So do we have some kind of color already? We have a color number. This would be a true color, which in theory we could parse further and actually break down. But we've got it right now as a 0. Oh, and this is a 32-bit. So I can see 1, 1, 2, maybe another 3. Maybe I should just copy that. I mean, really, I don't think our parser is going to care about the number of spaces. $427. And that kind of should have some extra processing done on it, but I don't know if we're actually going to use that. Six, 370, 390, 347, 348. Maybe those have some like undocumented significance, or maybe they have significance in the newer formats, which history. That would have been this morning. Doesn't have a time. Okay, so yes. Well, this might end up not being useful. Well, this is up to 2018. So we're having problems with the 220 range. Double precision floating point here. $220. Was it 220? No, it's like 220 something, wasn't it? Y and Z values for extrusion direction. Well, I might come back to that when I actually see the number coming up unknown. Did I find something else? Okay. There was this thing, which is like the, I don't know, search engine version of it. That's the same thing. Maybe I was just clicking around in there. Oh, nope, this bumped me back to recent time. Maybe. Or did touching these URLs bump them up in my history? Well, that means I got all of the things I was looking at, I guess. Okay. Is something else we were looking at? $227. No, that's a 330. No, that's 330, 227, 100. 5, 234. Was 40 special? No, 40 to 48. Five, 330, 100. L-type shape dot shapex. We got all the small integers, right? 3, 4. QCAD shape dot shapex. And tab 2 UCS 5 and tab table app ID. No, 2 app ID 5. What's kind of object reference? Producing program. Yeah, we had 70s. 140? Yeah, we just did those as XYZ. So that's yeah, we just did that as a float value. Oh, do you specify those? Points, elevations, dim style settings. It's not very well specified now. $340. paper space. Well, maybe when you start looking at higher level structures. $350. Let's read at 350. No. Soft owner handle. Well, okay, we almost have that by implication. $290? Yeah, $290 is Boolean. We had 420, so that covers 421. No, 5, 306, 330. That looks like it might be something peculiar. 5, 311. Arbitrary binary chunks with the same representation and limits as 1004 group codes. Oh, we haven't gotten into these. Chunk of bytes. Oh boy. Extended data control string, although this looks like 102, not 1002. Arbitrary binary, arbitrary text strings, arbitrary. Oh boy. So 311, arbitrary binary chunk. But it's just a 102. Wait. Is 102 part of the data? No, this is a dictionary. 5, 311, 102. Control string. By an arbitrary name or close bracket, similar to the xdata 1002 group, can be followed by arbitrary strings up to the application. Is close bracket as a terminator. Does not interpret these strings except during drawing audit operations. They are for application use. This is to say this data belongs to this group, I guess. All right, this is a 102. This is not just a string value, though. This is a very special set of values. At which point we should really just say, yeah, these all ended up mapping to the type, which is, maybe I should leave that here, because nothing else is doing that, doing their type here. While you wait for code. Control string start. DXF parser of strings. Oh, actually a 102. Is going to be a one-of parser. That's just going to determine the type of this. So unless I pass back information up here to make the decision of what kind of return value, we just kind of have to decide it there. Which means you have to return whatever this is, a value. No, this is a strict one of. It can succeed with a control string start, which actually we just only can only do the one right now, which has to eat the symbol token and then a string and no leading spaces. I guess we just do this on each of them. Can I actually do string value here? It's string value, probably had to do a chomp. Oh, now you do have to deal with the new line, though. Didn't I call it new line? No, I called it new line. Oh, but it's a symbol new line. No, I didn't like that. Okay, so we have start, we have object ID and end. So this is just saying reactors, and maybe this is a list of object IDs. Got 280 int value. That's 5, 230, 102. $350, 05. These are big old files. Three A9, B1, B2, B3, B4. And those are 350s again. Three 250 to 350, that's 251 is the value. Lots of dictionary settings, plot settings. $140. $1020 coordinates. $300. Arbitrary text strings. Okay. Do I just call this text? I don't know if anybody cares about the code used. If they do, we'll have a problem. $300 to $309. $140. Got $140. Things like defining a bunch of scale ratios, I guess. Can you tell what this is? Standard. Seen 7, I think. 170 we haven't seen. Representing dim style settings. But I don't know if it's going to be any different. How is it different from 280? Oh, okay, I saw type 2 input 3. '62, '63. We had 280, so I think we got the range. Yeah. $270. $16-bit integer. Well, value versus values. That almost seems like a typo. So why? I guess because they're just doing every 10. Oh wait, were you indented? I keep forgetting to look for that. Okay, you were technically. Gee, how are negatives handled indentation? Yeah, I think that takes up the space. $64. Oop. Still undocumented. $75 to $85, $65. It seems to be kind of like we're using these in sets. 62, 83. Some of the things are like, I need a code for this type. Use whatever. Got 250, I think. No, that's 5. 250 and then that. Lots of 176. I just dim style? Why 176? There's lots of them though. That seems to be a good part of the file. Okay, a little bit something different at the end. Dictionary var. Well, there's 1,000. We got 280. Looks like a different type of color code. But this is just ASCII string. Do we care if that's different than text? I'm not sure why it would matter. This is only looking like that exact code. Zero X record. Okay, so those seem pretty standard. So yeah, another string, full color. Auto. It's like document settings. I think at some point they fall down to some like pretty generic key value type things. They're like storing their values with this weird format. I don't know why they sometimes use one thing for a string and sometimes something else. Is 300s a range? 300s is a range. $236? Or is it a 340? 92 to 340, 230, okay. 90 was a range. Okay, no, that's a 0 EOF, so that's slightly higher level structure. Did I actually replace this? Eh. Okay, variable associated group code. It's kind of like the data type, I guess. I guess I'm gonna have to look through these to see if there's anything I care about. But we need to, okay, so we've got variable is in within a code. Well, we've got section parsing. So what does our structure even look like here? We've got sections, we've got section header. And then that goes variable value. I almost want to say that we should actually relook at this as, we want to say a file is a parser of like section header and then blah. Well, I guess it's defined this way so that in theory you could do these sections in any order. Ooh, although parser-wise, you'd have to commit to the 2 before you got to the header. So that would have to be operating at a slightly higher level. a token level that was similar to the parser level, but operating at a slightly higher level of abstraction. So the top level of a document, or a neutral state of parsing, would expect to get a section. Is it a section boundary? And we'd probably expect that to be header. What do we want to parse that as? We could have a thing to parse a section start as like header. And assuming we have an end section, we have a start section or end of file. End sec. Might be able to set that up as a kind of interim thing where it does like section name any number of values until we get to end sec. And then do that. We'd have to set up loops we won't necessarily use later. Okay, we had to add parser. We ignored all that extra CAD stuff. This is kind of a stopping point. We don't have a full parser yet, but we have a lot of stuff. What do I want to parse this as? Yeah, I think I prefer the scannability for certain sections here. Oh. Type of data follows. The meaning of the data element from an object or record. Appear in both the block and entity section. We haven't got to sections yet. Because this doesn't sync with that. That's the stuff we're looking at. Header section. File formats. Oh, ASCII versus binary. Okay. The group 0 followed by a group 2, name of the section. Header, classes, tables, blocks, entities, objects, thumbnail image. So we'd want to parse section name, stuff and section. I'm not sure if I want to do, like, the section parses a whole bunch of stuff, or you have the parser that, so you could do a section parser that returns a whole bunch of values. I almost wonder if you should parse the entire thing to values and then sort of do a parser on top of that. Well, I think this is probably a good enough breaking point. Since we're kind of going into a major another level. Just to call it for night and get some sleep. Thanks for watching. Thanks to support from my subscribers. So I'm usually on. Mondays are always a toss-up, and sometimes it'll be games. Most of the week is actually kind of when I feel like it. I'm not normally doing a whole lot of coding in the evening. I don't know if I've got anybody else to recommend. What's this? Ah, okay, that was a misattributed game. There's Subnautica. I started below zero recently.
Yeah. Ah!
Yep. I'd swear I hit me on that. Looking for some place cool to hang out. Zed first playing Subnautica. He's back in Classic. Looks like he's got a pretty good storage system going in there, so it must be fairly far into the game. If you're looking for someplace cool to hang out, that's someplace cool to hang out. Thanks for hanging out with me. Good night, and until next time.